Hi, welcome to the Maker Show. My name is Jeff Krepke, and what we're going to be doing today is tearing down a UPS in order to have a case for a couple of the CNC pieces of equipment that we're going to build in the future. Right over here is the APC, and I'll get a couple shots of that now. Okay, what we got right here is an APC. It's a 2002. Let me see. Where's the? It's an SMT 2200. I don't know if you can make that out on the video, but I got this. Company I was working for was actually going to be throwing this away, and I said, don't throw it away, give it to me. So that's what happened. You can see we have a really nice heavy-duty cord. This is what was running their server room, one of their interruptible power supplies for their server room. It's got a 12-gauge power cord, which can handle up to 20 amps. I don't think we're going to be pushing that in any of our projects. But you can see there's some good circuit breakers back here that we can salvage, some outlets. This one we could put in the shop or something, as it's a regular outlet. Okay, we'll go ahead and start with the teardown. Okay, I just wanted to give you a quick look at the front. This is where the battery connects in. Sorry, I just bumped the camera a little bit there. It came with this cover panel right here, went on the front. It's got a battery disconnect there for the big battery inside. It's got a display port here. This is a fully functioning unit. I ended up getting two of them, so there was no reason to keep two of them. I don't have that need. So, but I do need a CNC case to handle my CNC equipment. So I'm going to go ahead and start the teardown now. Okay, we'll start this teardown with an assortment of tools, some big screwdrivers, a pair of pliers, a multi-screwdriver. We're just going to go ahead and start taking screws out. I just wanted to let the people know out in YouTube land that 6 months ago I had known about YouTube and used it a couple times and found some interesting videos, but about 6 months ago I started finding videos that I really loved concerning CNC machines, and a couple shout outs of the channels I watch a lot and are really a fan of is the Ben Heck Show, the EEV blog, let's see, which other ones have there's some guy named Demers who has a really nice YouTube channel that deals with building the gingery lathe, which is one of the things we're going to plan on doing in this show, building a gingery lathe. We're going to try to work through all the 7 books in the series, how to build your own machine shop from scratch. So we're going to be setting up a foundry in order to accomplish that, as well as different kinds of sources. I'm here in Alaska, so It's not like the lower 48 where you can just run out to the store and buy things. Okay, we're going to crack the case here. It's always a little exciting. We have, let me turn it around. Okay, this is perfect. This is 2 extra large transformers, and I think I'm going to do a video where I actually make an arc welder out of these 2 transformers here. I was really hoping that they would be large and I'd be able to do that. I think it's the YouTube channel is the King of Random. He did a YouTube video about, let me move this up a little bit. I did a YouTube video about making arc welders out of recovered transformers you got out of microwaves. He ended up having to break those apart and rewind the coils on them to make them proper. But you can see how heavy duty that cable is. Let me try to read it here. We have 8 gauge. So if I do end up having to rewire it, they're large enough that it should accept lots of turns of wire. Okay, right now I'm disconnecting a 15 amp fuse, really nice one. Got some really nice ends on these wires. These are serious pieces of equipment. I looked one of these up online, and talking about $800 to buy one new out of the box. And these did come out of service, so look, they do both work. They're fully functional. And he said, well, if it's fully functional, why don't you just use it? Well, I got 2 of them, and I just didn't see the need to have 2 huge power supply or UPSs. I also got a smaller UPS. It's rated at 600 watt, which is going to be plenty to run my desktop machine, as well as my router, my cable modem. So just in case the power goes out, I'll be able to still surf the web for a little while. Okay, I'm going to take out a few more screws in back here. You know, and imagine this, it wouldn't have actually gone to a landfill. It would have gone to an electronics recycler. But, you know, they pretty much just grind things up and use the raw materials. And that's probably done not in Alaska, but done someplace else. So they probably would have been shipped out. And it's just nice to be able to recycle stuff locally. And that's what we're going to do. We're going to take as many of these parts out as possible. This is the first board. Okay, let's see if you can see that. It's a little bit dark. Sorry about that. I'll get us some better shots in the light. But we got a nice relay, a couple nice relays, 24 volts, some caps. Sure, there's some temperature sensing on here. A couple good Molex plugs, a nice muffin fan, and that's an expansion port for something that this one didn't come with. So we'll set that aside. And let me tip the camera down here. You can see that extra big transformers there. Let me zoom in a little bit here. Very nice, huge transformers. This is the power inverter board. Also power sensing for when it's sensing that there's no AC line and it kicks on. How I got started in the maker movement was that I love things apart. Let me move this over so you can see me a little bit. How I got involved in the maker movement is just kind of by luck. I had really understanding parents who supported me taking apart stuff when I was started doing it when I was 2. Taking apart can openers from like Value Village or Goodwill, and when I was 5, I got an electronics project set for Christmas, I believe, and started to put all the projects together and learn about diodes and transistors and resistors and capacitors, things like that, and just always loved it. I got an almost degree in electronic technology from Spokane Community College in Spokane, Washington, which was great education. I didn't end up finishing it. My dad ended up passing away before I finished, so I ended up having to go be with the family and stuff, and wasn't able to finish my education, which I really regret. And you know, someday I would like to get some more education. Unfortunately, in Alaska, there's not really electronic industry up here. There's really not a manufacturing industry at all in here. So if I don't, but I do want to develop a maker space. Got my new house that we're buying. We have not bought it yet. Oh, look at that ferrite core right there. That's huge. I'm going to put that off to the side. And we got this loosened up. That's the back side of the outlets. Them 3 really nice, one 215 amp and 120 amp circuit breaker. Pretty nice. We're going to go ahead and strip those parts off, and then we're going to eventually reassemble this case so that we can use it for our CNC machines. The first CNC machine, I'm not sure whether it's going to be a CNC router or a CNC mill or a CNC lathe. Because they're all just super helpful to the maker movement. And if you haven't looked into one, they're just super useful. Okay, we got, this is where the power cord comes out to a Molex plug, and this is also, not sure, let's see, this is a 250 amp through 50 volt AC circuit breaker. I don't see, I believe it's a 30 amp circuit breaker. Look at that long cord. I'm like 6 feet tall, so that's 6, probably almost a 10-foot cord. Went and bought that at the store, 10 gauge wire, 10 feet, and a cord like that, you're probably talking, I'd say $1 a foot probably, would be a good guess. And down here is actually the battery compartment. And what we're going to do is go ahead and I'm going to pick up some of these screws. And we're actually going to rotate this around, and there's a couple more screws in front, in the front panel. I'm going to go ahead and work on that now. Put those off to the side. Okay, I'm going to spin this. This is just the kitchen table. Wife and kids are off at school and work, so I thought I'd take over the kitchen table for a bit here. When we buy our new house, which should close any day, we're going to go ahead. I'm going to have a 2-car garage, totally wired for 220, but other than being wired for 220, there's nothing in the place. So it's going to be a blank slate. So we're going to be working on building workbenches and CNC equipment and that sort of thing. What I'm thinking about doing, which would be really cool, is actually thinking about going whole hog and designing a 4x8 CNC router. I'll take a full sheet of plywood. So the idea being, why would you want something smaller than the, what you'd want to throw down a 4x8 sheet of plywood? Cut it out, make some furniture, make a Neem cabinet, which we'll probably do on the show. This is the battery door right here. Behind here we have some very, very heavy batteries. It's a good thing I didn't hurt my back getting these in here, but these, oh, nice, look at that. Oh, those are heavy. Let me turn that around. Sorry you didn't see that, guys. Let me get it focused here. There's 2 sets of those, and these are lead acid gel cells. It said sealed, non-spillable lead acid. These would be kind of what you'd have in like an electric wheelchair or something. See a really nice big, forget what you call these connectors, but they're for connecting batteries up. This probably in a future project, I'm thinking robot. So be tuned for that. We'll probably make a big base unit because these are heavy. We'll put this right at the base. I'll run a couple big, probably if I can find some surplus wheelchair motors, those might be perfect for that. So I'm going to put these aside. And not only do I have 2 like that, but I actually have 4. Look at that baby. Okay, I was going to find a number here of what they were. It looks like it's the part number is 911-0050A, and I can't find a rating anywhere, but that's huge and that's beautiful. That'll definitely come in handy. And I got a whole nother one, so I got 2 more just like that. So it's a good thing I didn't hurt my back moving this thing over, because these weigh about 120 pounds. I think it said like 53 kilograms, which is 2.2 pounds to the kilogram. So we're talking heavy. I had problems getting both of these in from the car. They were so heavy. And of course it's just me. I don't get any help around here. My wife doesn't really understand electronics, and you know, it's like I'm speaking a foreign language when I talk about electronics. So, but I'm a strong boy. I got him in, and got him put behind the couch. My wife didn't complain too much. So, and these are the heavy-duty switching capacitors, or I'm sorry, switching like PFETs or NFETs, field effect transistors. And oh, I got a little wire tie here. These are the world's best scissors. These are Cutco shears. Anything Cutco. Talk about some awesome knives and awesome tools. I've had these for probably 10 years, going on 10 years, and seriously, they cut like the day they came out of the factory. They're really amazing. Okay, so what do we got here? I'm going to try to turn this around. Now it's a lot lighter here. We still have those giant transformers, though. This covers. Okay, there's a few more screws to move here. Okay, I'm going to get a shot. There we go. This is just beautiful. This is so well made. Well, it's got to be well made. It was backing up servers for a large company, so I mean they don't skimp. You know, they want the best, because you know, even if there's like a brownout condition, these will take over from the mains and start supplying power. There's another one of those big giant ferrites right there. I got 4 wires coming in on the primary, and then it looks like 2 wires coming off on the second. UPSs, they work both ways. Half the time these transformers are acting as a normal transformer, a step-down transformer, which would bring the line voltage of 120 down to, oh, that's that really nice fuse. That's a 100 amp automotive fuse. This would be for 12 volts. That could be the main fuse on the robot in the future. Keep that. It's probably a $5 fuse or more. If I was doing a big radio system in my car, that would be really nice. Okay, we got. Okay, yeah. See, there's a ferrite core in there for RMF. Okay, as much as I don't want to take this ferrite core right here apart, I'm going to snip it away. Let you see, you all see what's on the inside. These are wrapped in a ferrite. Boy, I don't think I'm going to be able to get that off as they're twisted around. I'm going to have to disconnect them from the board. So let's go ahead and take these coils off, or these transformers. Now, they act as step-up transformers when it's in backup mode, which means it takes the 12 or 24 volts supplied by the batteries and jumps it up to the 120 volts to run the power in backup mode. Now these individual, oh, there we go, pop. And there's a clip down here. Quite get it. That's all soldered on. As much as I hate to do it, I probably will be cutting some wires. Just because of the way this is wired. Okay, let's see if we can get these out. Those are really nice pass-throughs. Let's see if we can hold it. Oh yeah, got that connector through. Did you see that? Alright. Okay, let's do, oh, and that one's definitely going to be cut. As much as I hate to do it, I think I'm going to cut it right here so I maximize the length of the wires. Oh. Super shears. Don't leave home without them. Okay, I'm going to back those wires out. And these, I believe, are going to go to the battery connectors, which are somewhere. Not sure if I can get to them quite yet, but okay, I'm going to remove the other transformer now. There's some really nice, there's some ribbon cable. It's like about, there's a dip connector, dual inline package, I believe. As much as I'm gone to school and stuff, I'm not super up on the theory. Not an electrical engineer by far. You know, I respect those people a lot. They can just design something, but I'm not quite there yet. I take full advantage of, oh yeah, there we go. We got it, guys. And gals. I'm sure there's some women out there watching. But that is a beefy. That is probably 10 pounds, I would say. I got 2 of them. So, I'm going to be doing some experiments, whether I can link those together and make a arc welder. Now, it's probably not going to be super powerful arc welder, but you know, it's going to be nearly free. Okay, wow. We've got it down to maybe 5 pounds now. We got all the heavy components out. Just trying to get this front panel off. Does it have a screw? Yeah, it's got a screw. Let's take care of that real quick. I want to try to keep this in as good a shape as possible. Because once we tear this down, we're going to put it back together. Because this is, oh yeah, see, it's this plastic case. There's a little more ferrite right here, and then that whole control panel is behind this cover here. So I'm not going to worry about that. I'm just going to set that off to the side. Nice panel there. And then we've really exposed this main board here. Another really nice connection breakout. Okay, so take a look at the board for the first time. I'm hoping you can see it. I'm going to zoom in a little bit. I don't have any fancy lenses or anything like some of the guys, but I'm just starting out. So with your support, guys, I'm sure we can get me some more better camera equipment. That's kind of cool. A little plastic piece to hold these really super tall caps in place. And I see 3 field effect transformers or transistors on each of these power. In the middle there's 3 more, so there's a total of 12 high current capacity MOSFETs, which we can probably recover and make some H bridges and stuff for a robot project or something like that. And other than that, it looks like a lot of surface mount componentry, which you know, they went through hole when they really had to. Okay, that's loose. So we had 1 screw, guys, and we're loose. I'm gonna get this one connection, and voila! Look at that, guys. That is beautiful. That is beautiful. It's probably about 2-3 pounds. It's got down here. It's got a that's a ROM chip that handles all the functionality. There's some smaller. There's a couple smaller transformers. 1, 2, 3, 4, 5, 6, 7, 8. Really nice relays. Okay, and on the back we got really nice board here. I repaired PC boards for a company in Spokane, Washington before I moved up to Alaska, and did surface mount repair as well as through-hole component repair. And that there is a super nice board. Okay, well, I think I'm going to end the video there, and you will see this case in an upcoming video. Sorry, let me get on the frame here. I'll zoom out a little bit. You'll see this case here on an upcoming video, and we can fit an awful lot of motor drivers and that sort of thing in this case when we get about doing that. Not sure it's big enough to house the computer board as well as the CNC controllers and stuff. The other thing I'd really like to do during this series, oh, I see how it is. Okay, we got a couple more screws here to get those battery connectors out, and that's pretty important because I don't want to be clipping those connections off the batteries if I can help it. I want them to go on and off just like they were made to in the factory. So that way APCs are so common that I can just order the batteries by the interruptible power supply's number and get really nice, get all new batteries for this. And because there's a lot of these prices for those batteries are pretty reasonable. And I'm sure they come with the connectors pre-installed. So it's going to be a really easy job. Okay, look at that. That's super nice. This is where the transformers clip in and then have 2 screws. So this is going to probably be the basis of the arc welder right here. Will mount both transformers and then wire them up. Preferably, I would say in parallel, but possibly series. I'm going to have to look into that a little bit more, but having a base plate like this is it's gonna be really super nice. Okay, so that exposed the 2 screws for the battery connectors, and I'll get those out right now. Now, I've been interested in electronics since I was about 10 years old, and always wanted to build electronics. That was well before Arduino and that sort of easy development boards came about. Really, people had known what CNC was back then, but they were, you know, $100,000 machines. They weren't something that, you know, a tinkerer like myself could touch. So, okay, I'm going to cut these 2 wires here, these 2 yellows, and because they're linked through the chassis. They're just no way to get them out without doing them. Okay. So there we go, guys. Beautiful battery connector ready to go. I already got pre-attached wires. That's going to be awesome. And this was designed to series wire the battery together. Two negatives, 2 positives, both at 24 volts probably. I'd have to do some testing with the multimeter to be sure on that. And then this right here, let me get it out for you guys. I'll cut that. It's really solid in there, and we'll get a different angle on it. Alright, super shears win again. Okay, this is a thermistor, and it's already got the connector. These are used in hot ends on 3D printers. And it was sensing the temperature of the batteries, and if the batteries got too hot, it would shut down the machine. Okay, so I'm going to do a little bit of wrap up here. I'm going to take the camera off the stand, and you can take a look at what the parts we got. Okay, so we have the mounting plate for the transformers, the main board, and this is largely just going to be parted out in the future. I'm not going to try to reuse that board as is. This is one of the front plates that went right here on the case, and I'll go ahead and reinstall that. This is the front panel up here. This was the backboard right here with the muffin fan, and this was the outlets and the power cord coming in. All in all, guys, I'm going to give you a preview here. These are all super usable parts that someone's going to simply throw in the garbage. So I appreciate it, and I'm going to go ahead and clip this in with some other videos, or I'm going to post the other videos separately of the suppliers I've found in the area. And I appreciate you watching my first video. Thanks. Bye.